Hello dear students, this is your Engineering Mathematics 3 lecture. Today's topic is integral equation. This topic is from second unit, Fourier second unit, and in second unit the topic Fourier transform. Integral equation. Example, solve the integral equation, integration was 0 to infinity f of x sine lambda x dx is equal to e raised to minus lambda, where lambda is greater than 0. The solution for this equation, integral equation. Now here the given integral is integration or 0 to infinity f of x sine lambda x dx is equal to e raised to minus lambda. Lambda is greater than 0. Now this integration, in this integration, dx is the differential here. Dx is the differential, means x is variable, and so lambda is constant term with respect to integration. With respect to integration. Okay. Now this is a definite integration. So if we replace this x by u, we have the integration over 0 to infinity f of u sine lambda u du. And this term is nothing but the integration of Fourier transform, Fourier sine transform. This LHS side is nothing but Fourier sine transform. This is the formula of Fourier sine transform. And this is, it is nothing but e raised to minus lambda. So we have given the value of sine, Fourier sine transform. We have given the value of Fourier sine transform. This is clear from this integration. Okay. Now, as sine lambda x is present in the integrand, we use Fourier sine transform, and so the value of Fourier sine transform is equal to e raised to minus lambda. This is clear. Now, to find f of x, means inverse Fourier sine transform, we use inverse Fourier sine transform formula. F of x is equal to the formula f of x is equal to 2 upon pi into integration or 0 to infinity fs lambda, f suffix s for sine transform, fs lambda into sine lambda x d lambda. It is equal to 2 upon pi integration or 0 to infinity f suffix s lambda sine transform. Now its value is given in the example, it is e raised to minus lambda. So you replace fs lambda by e raised to minus lambda into sine lambda x d lambda. Now 2 upon pi as it is. Now how to solve this integration? Integration over 0 to infinity e raised to minus lambda into sine lambda x d lambda. Here there is a product of two functions, but we cannot use here u into v rule, that is integration by parts, because one of the function is their exponential function and we can differentiate it n times. So derivative is not vanishing. Similarly, the second function is sine function and we can differentiate this function also n times. Its derivative is not vanishing. Can differentiate it n times. So derivative is not vanishing for either function. So we cannot use here u into v rule to solve this integration. And there is one standard formula to solve this integration. That formula is here, is mentioned here. See, formula is first is integration e raised to x into sine bx dx is equal to e raised to x into e raised to x upon a square plus b square, where a is coefficient of exponential function and b is coefficient of sine function. So e raised to x upon a square plus b square in bracket a sine bx minus b cos bx. And second formula, integration e raised to x into cos bx dx. It is equal to e raised to x upon a square plus b square into a cos bx plus b sin bx. So we are going to use this formula here, that integration, so integration of 0 to infinity e raised to minus lambda into sine lambda x d lambda. Here the coefficient of exponential function is -1, because with respect to this integration lambda is variable and the coefficient of lambda in exponential function is -1, and in sine function the coefficient of sine function is x, because lambda is variable and with lambda the constant term is x. So the value of for constant coefficient is x. So use the formula that e raised to x, this first formula e raised to x into sine bx dx. See here, the value of a is here -1 and the value of b is x. So using this first formula that a is -1 and b is x, 2 upon pi as it is inside the bracket e raised to minus lambda upon a square plus b square. A is here -1, so square of -1 square plus b is here x, so square of x is x square. Write in bracket a sine bx. A is here -1, so -1 into sine lambda x minus sine for second term because of formula into b cos bx. B is here x, b cos lambda x. Bracket complete and the limit 0 to infinity. Okay, now the upper limit is infinity, so put lambda is equal to infinity because lambda is variable here in this integration. So replace lambda by upper limit infinity. 2 upon pi as it is. E raised to minus infinity. E raised to minus infinity is 0. So after putting upper limit infinity, e raised to minus infinity is 0. So the first term is 0. Now negative sign, give negative sign for lower limit. Lower limit is here 0. So give negative sign here. Then put lambda is equal to 0. E raised to 0. E raised to 0 means 1. So right here 1 upon -1 square is 1 plus x square. So the term is 1 upon 1 plus x square. Now inside the bracket, we are putting lambda is equal to 0. Sin 0 is 0. So this first term is 0. Minus x into cos 0. Cos 0 is 1. So minus x in bracket. So this minus and this minus sign get plus. And so the term is f of x is equal to 2 upon pi into x upon 1 plus x square. And so this is your answer. This is the solution of the integral equation. Okay. Now the next example, solve the integral equation. Integration of 0 to infinity f of x cos lambda x dx is equal to it is defined in two intervals. First 1 minus lambda when lambda lies between 0 to 1. And the second interval is 0 when lambda is greater than 1. So 1 is the point of discontinuity here. As cos lambda x is present in the integrand. See what is the RHS, what is the LHS term of the equation, integral equation. Integration of 0 to infinity f of x cos lambda x dx. If we replace, this is definite integral, so we can change the variable here. So if we replace that x by u, the formula will be f of u. Sorry, the LHS side will be f of u integration of 0 to infinity f of u cos lambda u du. This is nothing but the formula of Fourier cosine transform, and its value is given. It is defined in two intervals from 0 to 1 and 1 to infinity. So you write here as cos lambda x is present in the integrand, we use Fourier cosine transform, and it is fc lambda is equal to integration or 0 to infinity f of x cos lambda x dx is equal to, it is defined in two intervals, 1 minus lambda when lambda is in 0 to 1, and it is 0 when lambda is greater than 1. Now to find f of x, consider inverse Fourier cosine transform. We are going to solve this integral equation, so we are going to find the inverse Fourier cosine transform, and the formula for inverse Fourier cosine transform is f of x is equal to 2 upon pi into integration of 0 to infinity fc lambda into cos lambda x d lambda. Now here put the value of fc lambda. Fc lambda means Fourier cosine transform, and it is defined in two intervals from 0 to 1 and 1 to infinity. So 2 upon pi as it is, integration of 0 to 1, function is 1 minus lambda. So put fc lambda is equal to 1 minus lambda into cos lambda x d lambda plus from 1 to infinity, the function Fourier cosine transform is 0. So second integration is 0. Now solve this integration. 2 upon pi as it is. The first integration of 0 to 1, 1 minus lambda into cos lambda x d lambda. Now there is a product of two functions. One of them is linear term 1 minus lambda, and second one is cos function cos lambda x. Integration is with respect to lambda. Lambda is variable, so use here u into v rule because derivative of 1 minus lambda vanishes earlier as compared to derivative of cos function. So use here the general formula of u into v. So u is here 1 minus lambda because its derivative vanishes earlier. So 1 minus lambda is your u into v1. v1 means integration of cos function. Integration of cos lambda x is sin lambda x upon x, because constant term is here x, lambda is variable. So integration of cos function is sin lambda x upon x minus u negative sin to second term by the formula into, sorry, minus sign, then derivative of 1 minus lambda with respect to lambda. Derivative of 1 is 0 and minus lambda is minus 1. So write in bracket minus 1, in another bracket v2. v2 means integration of v1. v1 is there sin lambda x upon x. X is constant, so as it is, v1 by x is as it is. Sin lambda x integration is minus cos lambda x upon x. Already x is there, so x into x, x square. So this is the integration of v1. u into v1 minus u dash v2. Next term, u double dash means derivative of this minus 1. Derivative of minus 1 is 0, so no need to write it. So the all the next terms are zeros, so no need to write, stop here, and the limits 0 to 1. Now the variable is here lambda, so you put lambda is equal to 1 upper limit, so 2 upon pi as it is. Now lambda is equal to 1 means 1 minus 1 0, 1 minus 1 0 means 0 into this term is 0, first term 0, minus minus plus, again the minus sign is there, so give minus sign here, cos x, because lambda is 1, cos x upon x square. Okay, cos x upon x square. Now put lower limit 0. Lower limit 0 means lambda is equal to 0. For lower limit, you give negative sign to every term. Minus sign, sin 0, because we are putting lambda is equal to 0. Sin 0, 0, so this term is 0. Minus minus plus, minus sign and the minus sign of lower limit, minus minus plus. And the lower limit is 0, so put lambda is equal to 0. Cos 0 is 1, 1 upon x square. And here f of x is equal to 2 upon pi as it is. Now denominator is same here, x square, so we can do the addition of numerator. So 1 minus cos x upon x square. So the function is f of x is equal to 2 upon pi in the bracket 1 minus cos x upon x square. So this is the solution for the integral equation. So you solve the integral equation, means there the Fourier transform is given, either cosine transform or sine transform, whatever you can identify it easily from the given equation, and you have to just find the inverse Fourier transform, inverse Fourier cosine transform or sine transform. Here 4 examples are there for practice. You have to solve these examples, solve the integral equations. And so here the first topic Fourier transform is over. Thank you.